Today we're going to talk about solutions and this idea of solubility, so how things dissolve. So ionic compounds we know are made of positive ions and negative ions. And what will happen is they will dissolve in water. Water is very polar, meaning it has a very positive side for the hydrogens and a very negative side for the oxygens, just because of its particular structure. So when we have something like sodium chloride here, and we're going to dissolve sodium chloride in water, what's going to happen is the sodium and the chlorine are going to break up. So the sodium chloride is the solute, what you're dissolving, and the water is the solvent, what you're dissolving into. So as this happens, the sodium and the chloride, they break apart, and what's going to happen is they're going to arrange themselves. The sodium, which is positive, is going to arrange itself by the oxygens, and the chlorine that's negative is going to arrange itself by the positive hydrogens. We call sodium ions and any positive ion a cation, and we call any negative ions an anion. Okay. Now, most molecular compounds, like what you're made of, your skin and proteins and fats, aren't soluble. They don't dissolve, but there are some exceptions. Extremely polar molecules, like polar covalent molecules like glucose and sugars and things like that, will dissolve. And then very nonpolars will dissolve in other nonpolar compounds. So if you have like hexanes will dissolve like methane and stuff like that, just because they're both nonpolar. The other thing is if you're a very strong acid like HCl, HF, these guys, they will break apart and dissociate as well. Now ionic compounds that have a lower electrochemical attraction, they will break apart, like sodium chloride. The strength between the sodium and the chloride isn't super strong, so they will bust apart and they will form electrolytes, which just means there'll be positive and negative ions in your solution. That's what an electrolyte is. Other ionic compounds have a higher electrochemical reaction, like lead iodide, and these will precipitate out of a solution. Okay, and then you can use your solubility chart that you used in grade 11 to figure out what's what. So lower solubility is coming out of solution. Something that's soluble will stay in solution. So the other last, so not the last piece, but the next piece we're going to talk about is ways to calculate molarity, because there's multiple ways. Now we have dealt with molarity as concentration, I should say. Molarity is the way to do it, but there's other ways of doing it. You could calculate molality, which is grams divided by volume. And you can calculate percentages, which is the total amount of solute divided by the solvent. So the one where this is used for is generally alcohol, that you'd probably have seen before. So if something's 60% alcohol, that means by volume of a liter of that alcohol, 60% would be ethanol. And then the other 40% would be the aqueous solution, and then all the other flavorings, whatever. So that is how we'd use that to calculate a percentage. The other thing that we need to do is be able to figure out how to figure out the moles of, or the molarity, the concentration of individual ions. So here, I know it's a little bit hard to see with the glare, but I have 37 milliliters of 1.2 molar sodium chloride, and it's mixed with 48.0 milliliters of 0.8 molar calcium nitrate. And I want to know what are the ion concentrations. So a couple steps here. First thing is do a balanced chemical equation. Make sure you have your solubility chart next to you. We're going to go over how to use the solubility chart in a second, but make sure you have it with you. So right here I have two sodium chlorides and they're aqueous, and I have calcium nitrate and it's aqueous. We know that because they're in liquid and they have a molarity. So when I do this, I get calcium chloride and I get sodium nitrate, and I've had a balance, they're both aqueous. So how do I know that it's aqueous? Well, I gotta use my solubility chart. So here's my solubility chart here. And if you can see here, so here's my negative ions here, and here's my positive ions. So if I have something with chlorine in it, unless it's silver, lead 2, or copper, anything with chlorine is going to be soluble. Anything with a sodium ion is going to be soluble. So when we looked at our compound here, we made calcium chloride. Well, it's got chlorine, and this is not silver. This is not lead 2 or copper 1. Therefore, it's going to be aqueous. So if it says soluble, it means aqueous. If it says low solubility, it means solid. Here I have a nitrate and a sodium. If we look back at our charts, anything will remain soluble with sodium or any alkali metal. And nitrate, anything with nitrate will remain soluble. So those guys are just going to stick into the solution. So make sure you have that chart. We'll use it on the next class as well to figure it out. So next step is I'm going to calculate the moles of each, just molarity times volume, and I get 0.0444 moles of sodium chloride. And I do the same thing for the calcium nitrate. I get 0.360 moles for the calcium nitrate. So when I work through this, I'm going to get a value for each. Oops, so I made a mistake here. So this should be 0.044 and this should be 0.044 because I'm going to break them apart. So here's my sodium chloride, here's my sodium, this should be 0.044 right here. And here I go through this and I should make sure that this is 0.36 and then there's 2 of these, so it's 0.72. So it's double the amount of moles because I have twice the amount of moles. Here I work through, I think this should be 0.0912. Check that calculation. I think this one should be 0.0912 as well. They're the same because it's a 1-to-1 relationship. There's 1 sodium, 1 chlorine. Here I've doubled the amount for my molarity, okay? And so I can figure out what my final concentrations are for each. Just an important note, saturation of a solution happens when you can't dissolve any more of the solute in the solvent. So equilibrium happens at this point. So what I have is I've just dumped it as much as it will hold. I can't get any more in. Particles are going to come out of solution and they're going to go back in. They're going to come out and go back in. So basically what's going to happen is I have particles in the solution and then I keep dumping in more, they won't stay in. So I'm just going to go in. Particles are going to go into the solution and then come out of the solution, into the solution, out. So you're just going to have this equilibrium. And then any extra solute is going to precipitate out. Okay, so it's going to form a solid, it's going to come out. And then the only way we're going to be able to change the solubility is, once again, by changing the temperature. I hope that helps you understand this and helps you do the work for today. Thank you.